Here's problem 28.5. Consider the circuit shown in the figure. What power is dissipated by the entire circuit? If we're thinking power, at least in resistance, that would be either I squared R or V squared divided by R. If we were thinking of power in a battery, that would be the current times the voltage of the battery. Now in this case, we're asked for the power dissipated by the entire circuit. We could calculate the power dissipated by each resistor, in which case we'd have to find either the current or the voltage in each resistor in this circuit, calculate that, add them all up together, and get the power dissipated by the entire circuit. That would be a lot of work. Another way is to find the equivalent resistance of the whole circuit and find the power dissipated by that. That should be the same because the equivalent circuit is an equivalent representation of the whole circuit. It should dissipate the same exact power. It should have no different effect on the battery than any other representation of the circuit. So that's an easier method. So let's take a look at that. Let's simplify this circuit. We'll start with the series combination here on the end. We have a 3 plus a 4 plus a 3. That gives us 10 ohms. And now this circuit looks like this. We have a 28 volt battery, a 5 ohm resistor on top, 10 ohms here, 5 ohms on the bottom, and then we have a 3 ohms here, 10 ohms here, and 2 ohms on the bottom here. And now we've replaced that series combination with 10 ohms over here on the outside. So now we have a parallel combination of a 10 ohms with a 10 ohms. Our parallel will be product over the sum, 10 times 10 over 10 plus 10 will give us 100 over 20 or 5 ohms. So let's replace that parallel combination with 5 ohms, and now our circuit looks like this. 28 volt battery, 5 ohms on top, 10 ohms here, 5 ohms on the bottom, and we have 3 ohms here. And now we replace the parallel combination with 5 ohms and a 2 ohms down here. Now we have another series combination, 3 plus 5 plus 2, which gives us 10 ohms. And then that 10 ohms is going to be in parallel with this 10 ohms in the middle, and we just determined that 10 ohms in parallel is 5 ohms. So now our circuit looks like this. 28 volts, 5 ohms on top, now 5 ohms here, and a 5 ohms on the bottom. Now we have these 3 5 ohms in series, add them together, 15 ohms. So now our final circuit looks like this. 28 volts, 15 ohms, and that 15 ohms is our R equivalent. Nice to know. That's our equivalent resistance of this whole circuit. Let's start a new page here. So we could find the power dissipated in that 15 ohms. That power would be V squared over R, 28 volts squared over 15 ohms. And what does that give us? 28 squared divided by 15 gives us 52.3 watts. So there's 52.3 watts dissipated in this 15 ohm resistor, and that is the power dissipated in the entire circuit. Another way we could find power is the power put out by the battery. It should be the same power dissipated in the circuit, so it should be the same value. Let's see what the current coming out of the battery is. That current is the voltage divided by the equivalent resistance. So that is going to equal 28 volts divided by 15 ohms. And so the current coming out of the battery is 1.87 amps. And hence the power of the battery is the current times the voltage of the battery. And that would be 1.87 amps times 28 volts. And that gives us 52.3 watts. So we can see through the correlation here that the power dissipated by all the resistance, 52.3 watts, is equal to the power supplied by the battery, 52.3 watts. And so we could find either one to find the power dissipated in the circuit, because they should be equal, one and the same. So that's our answer to this problem, 52.3 watts.